we'll learn how to do thin layer chromatography for separation of amino acid. Thin layer chromatography is a chromatographic technique in which stationary phase is formed on a suitable flat surface such as glass plate or plastic plate. Since layer is so thin, the movement layer by capillary action is rapid. As mobile phase moves along the layer, one edge to the opposite, it transfers any analyte placed on the layer at a rate determined by the distribution coefficient, Kd, that is, distance travelled by analyte present in the stationary phase to mobile phase is later determined. The analyte moment ceases when mobile phase reaches the end of the layer or when plate is removed from the mobile reservoir. The moment of analyte is expressed as its retardation factor, that is RF. That is the ratio of a distance travelled by analyte from the origin to distance travelled by the solvent front from the origin. For performing thin layer chromatography, we'll need pre-coated TLC plate, and today we'll be separating amino acid which is present in the mixture. And we have three standard amino acid. One is threonine, another is methionine, and third one is lysine. Plate. We have prepared the line of origin and we have labeled as 1, 2, 3 and mixture. We'll start with 1 and subsequently all the 4 samples. For loading the sample, we'll use capillary tube. We'll take an amino acid in capillary tube and we'll load in plate. We'll load all the 4 samples one by one. We have to let, once we add a drop of sample into the plate, allow them to dry till we add another spot. Now we have loaded amino acid in the TLC plate. Number 1 is lysine, second is methionine, third is threonine, and fourth sample is mixture. Now we have loaded the sample and spots are dry. Now we are ready to place the plate into the solvent system. This solvent system contains butanol, acetic acid, water in the ratio of 8:2:2. On the basis of affinity towards water and butanol and acetic acid, amino acid will separate. And acetic acid also functions to provide humidity in the chamber. Now we are ready. Samples mobile phase is running through the plate. We'll remove the plate now when mobile phase is moved till the end of the other side. Now we can remove the plate from chamber and place it in 70° hot air oven to operate on the solvent system. Now, TLC plate is ready. We have sprayed the nitrite. After spraying, we have kept the plate in hot air oven at 81°. Now we'll calculate the RF value. RF value is the ratio of a distance travelled by spot from the line of origin to distance travelled by the solvent film. We'll calculate the RF value for all the spots we have detected. In mixture, we standard amino acid number 1 we have one spot, and number 2 we have 1 spot, and 3 we have 1 spot, and mixture we have 3 spots. So first we'll calculate the RF value of all the spots, and then mixture is 2. Spot number 2 it is 3.7 and spot number 3 it is 5.5. Solvent front for on the solvent front is 7.5. Now we'll calculate the R value, that is the ratio of distance traveled by amino acid to distance traveled by solvent front. So if we divide 2.1 by 7.5, we'll get 0.28 for lysine. Threonine it is 0.49. For methionine it is 0.73. And spot number 1 it is 0.27. Spot number 2 it is 4.9. And spot number 3 it is 7.3. That means our spot number 1 is lysine, whose RF value is similar to lysine. Spot number 2 is